Hello everyone, welcome to our presentation. My name is Xuhui Wang. I'm so excited to introduce our work LAVA, which stands for Logic Aware Validation and Augmentation Framework for Large-Scale Financial Document Auditing. Here's the flow for today's talk. Firstly, I will start with a problem and motivation, like why financial document validation is hard and high stakes. And then I will give an overview of Lava's architecture, followed by our novel verification and prompting strategies. Next, I will discuss the experiments, results, and ablation findings. And finally, I will wrap up with business impact and future directions. Now let's begin with the challenges that motivated this work. Financial institutions process millions of documents every day, from payrolls and tax forms to mortgage statements. So, a single miscalculation or misinterpretation can result in regulatory penalties or financial loss. So, accuracy and traceability are both critical. However, the documents are always complex, with the non standard layouts, the noisy scans, and the business rules that can vary across domains. At the same time, the existing large language model based solutions they offer suffer from hallucinations and poor logical consistencies and weak auditability. They might answer correctly in simple QA tasks, but fail when logic spans multiple views or involves arithmetic reasoning. Here are some examples that illustrate those challenges. Given a simple and clean pay stub, though in real world scenarios they could be extremely messy and complicated, or even should be considered together with other documents for some certain validation rules. The questions like, is the year to date total deduction computed as the sum of all deduction items? Or are pay period dates present and valid? The questions seem simple, but actually they require the model to understand structure, to understand layout, and logic and arithmetic at once. The traditional visual QA system or text extractors, they easily miss these dependencies, especially when the tables and content are irregular or when the rules involve multiple steps. These examples motivated us to design a logic aware, multi stage pipeline that doesn't just answer but verifies accurately and fast in a very low cost. Lava is built as a four-stage modular pipeline designed for transparency and auditability. Firstly, there is document and rule retrieval module. It identifies which documents and business rules are relevant for a specific validation task using a bidirectional constraint mechanism to narrow down the reasoning space. Secondly, there is knowledge extraction module. We use an HTML-like structure markup that preserves the layout and preserves the field relationships, combining OCR recovery and structural parsing. And then there is information augmentation frame, which enriches context with metadata like language, document type, and financial terminologies, routing each rule to the correct reasoning pathway, no matter it's symbolic or arithmetic. And finally, there is hybrid validation module where Lava performs both semantic reasoning through a symbolic reasoner and numerical checks through an arithmetic processor with the external formula execution. And this modular design makes the system interpretable and easy to audit, which is a major requirement in the real world enterprise workflows. Now let's look at the core innovation of Lava, its verification strategy and meta prompting framework. Our system separates the formula generation from computation. The large language model itself first produces a formula representation instead of calculating it directly. The formula is then executed deterministically by an external Python engine, and if the computed result doesn't match expectations, a checker loop with negative feedback triggers the model to regenerate the formula again. This tool use paradigm allows us to detect and correct the hallucinated calculations while maintaining a transparent audit trail. And equally important is our meta prompting design, which is a template based prompting method that dynamically incorporates the rule logic, metadata, and structured knowledge, which means that the prompts are actually not handcrafted for each case. Instead, they generalize well across heterogeneous financial documents. So, together, the formula check loop ensures accuracy, while meta prompting ensures scalability and robust generalization. We evaluated Lava on real world Canadian mortgage application documents, about 1,000 scanned PDFs across diverse financial forms. And rather than using the generic QA accuracy, we built the business aligned evaluation metrics directly reflecting the validation challenges in the real world financial auditing. These include the factual hallucination rate for content not grounded in source documents, and numerical infidelity rate for incorrect quantitative reasoning, and edge case handling rate measuring the robustness in complex rule exceptions, and finally the token efficiency for practical deployment cost. So this proposed evaluation framework captures the real operational requirements, giving us a much more meaningful view of system performance. And now to the results. We compared Lava with baselines of standard large language model based VQA and QA settings. Across all 5 rule categories, Lava achieved the lowest hallucination and numerical infidelity rates while also being more efficient, reducing the token usage by 25% to 45%. Importantly, these gains are not just tied to a specific foundation model. Our framework is model agnostic. We tested with Cloud 3.7 Sonnet, but Lava can integrate with actually any capable large language model backend. And the architecture handles logic and verification externally, so the improvements will scale up automatically as newer models emerge. In the ablation study, we found that removing each component like knowledge extraction, information augmentation, or arithmetic processor, they will all cause clear drops in accuracy, which confirms that the modules are functionally complementary to each other. From the business perspective, our design still pays off. This structured knowledge is executed and extracted once and reused across multiple rules, saving cost and latency. And even with all modules enabled, Lava still adds fewer than 3,000 tokens per rule, translating to very low cost per rule with the modern language model APIs. That is a very big deal for large-scale enterprise validation tasks. To wrap up, Lava provides a modular, interpretable, and logic-aware framework for financial document validation, and Lava transforms financial document auditing from a pure black box process into a more transparent, verifiable, and trustworthy system that is ready for real-world use cases. Thank you so much for watching our presentation.